Welcome to Business Analysis Techniques. This is week 7. We're in the summer of 2014 quarter. And this week, your reading involves chapter 8 of your online textbook. So make sure you're reading chapter 8 and reviewing the PowerPoints that I have here. You're also going to have discussion this week. And of course, there's an assignment. Our assignment in reading this week continues our study of linear programming. We've got some additional linear programming problems. So I want to get right into those and help you get started on that. So what we're going to do here is try to minimize the cost of staffing this restaurant. So you're going to, of course, read your paragraph with your instruction. But basically, you're going to determine the minimal cost per worker. So you're going to put a formula down here to minimize your cost of workers. So you're going to have your objective function, um, which is your cost per worker times the number of workers. And then you'll have the sum product. Well, I'm sorry, let me say that correctly just so nobody's confused. Down here in this area, you'll have your objective function, which is the cost per worker. Up here is, of course, where Solver will tell you how many workers per shift. In this cell is where you will put the sum product formula that will multiply this times this. Okay? So you put your sum product formula in there, just like you've done before. You're going to have some constraints, and your constraints are related to the 4-hour shifts. So the 4-hour period, start times. So you're going to have 3 to 7 a.m., 7 a.m. to 11 a.m. All these different start times, right? So you'll list them all there. And what you'll have to keep in mind is that for every 8-hour shift up here, there's 2 4-hour start times. So if somebody starts at 11 p.m. to 7 a.m. shift, that means they will be having start times at both 3 a.m. and at 11 p.m., right? So the start times are in 4-hour increments down here, but the shifts are in 8-hour increments up here. So basically what that means is when you put your constraint in, and you're going to put ones in down here to represent the number of employees starting at that time, this 3 a.m. or I'm sorry, this 3 a.m. to 7 a.m. shift or start time is going to include people in this first shift as well as this last shift. And so each of these start times is going to compass a 1 in 2 different shifts. So this 11 a.m. to 7 a.m., you're going to have a 1 here and here. And then as you add the other start times, remember you'll put all of your ones in so that each start time reflects each shift that it's in. So make sure you're reading through the paragraph to understand what I'm saying. And then you'll have all the ones here in your constraints. And so you're going to sum here. You've done a linear programming problem before. So this column is where you're going to put your sum product here, which is going to take this line times the number of workers. And then down here, you'll take this line times the number of workers. And then the next one, each line times the number of workers. You'll get all your sum products here. Then in this area, it tells you for each 4-hour period what the minimum number of workers is. For each 4-hour period. See, these numbers correspond to what you will have down here. So you could even just copy them, that way you don't have to retype. So now you've got them down here. And so once you've got your sum products here, these numbers will have to be greater than these numbers here for each shift. So that's the constraint that you'll have in Solver. For each shift, it needs to be greater than the minimum numbers given here. And so you're going to complete this problem in Solver using Simplex LP. So you're trying to minimize this by changing this subject to these constraints. Okay, so that's problem 1. Let's move over to problem 2 and look at some things here. And in problem 2, you're trying to determine the correct mixture of ingredients in order to maximize profit for this product. And so you're going to, of course, read through your entire paragraph because I can't cover everything on here. I just want to get you the outline. But so read through your entire paragraph, but basically your constraints are going to be the amounts of each of these ingredients, and you'll also have a maximum that you'll have to use as a constraint. So read through the paragraph and you'll have all of the constraints here. So you'll have the amount of ingredient A that are in the oats, the amount of ingredient A that's in grain, the amount of ingredient A that's in the mineral, and you'll repeat that for each ingredient. And you'll have your sum products here. And up here is where it tells you the minimum daily requirements that these things need to be greater than. Then you also will get in your paragraph the information about the maximum. So when you have a max here, that means this number needs to be less than the maximum given in your instructions. And this problem, you're going to run in GRG nonlinear, and you will be maximizing this by changing these cells subject to these constraints. Look at problem 3. And again, you've got all your detailed instructions in this paragraph. You're going to set up some advertising budgets, and you want to maximize the number of people that you can reach. So your objective function is going to be the number of people reached by each of these mediums. And so you're going to maximize this using the sum product formula. And then your constraints are going to be the different types of advertising that you can do. So you've got a constraint on TV advertising, radio, billboards, newspaper. Then you're going to have a constraint that says TV and or radio. So that's a separate constraint. Then you're going to have a constraint that says billboards and newspaper. So that's a different constraint. Then you'll have a constraint regarding the total cost. So these are the constraints that you will have. So look up in your paragraph, in your instructions, and it will give you what the constraints are for each of these. It says like that your advertising budget has been set at $15,000, so your total cost must be less than or equal to that. It tells you that each type of ad can't be used more than 10 times, so your constraint on each of the individual types is less than or equal to 10. So you're going to work through all of your constraints, and you're trying to maximize reach by changing the different types of ads subject to these constraints. And there is a problem similar, very similar to this one, that's actually in the textbook that you can use as a guide as well. And then the last problem for this unit on linear programming is our stock problem here. So you've got 3 paragraphs up here in blue to give you the instructions. And you're going to try to minimize the beta on this portfolio. So make sure what you're doing here, when you get to solver, you're trying to minimize this cell. Instead, usually we maximize. We're trying to minimize this cell. The objective functions are the betas given for each of those stocks. And then the constraints are going to be that each stock can be no more than a certain amount of the portfolio. So you'll have to list that for all 5 stocks should be less than or equal to the maximum percentage of the portfolio. And then what you're going to do is tell it that the entire proportion has to equal 1. so that you won't have like 35% of each one and there's five stocks, so you'll end up with 150%. You have to have a total proportion of that equals one, and no single stock can be more than 35%. You also are going to have a constraint about the expected return. The expected return needs to be greater than or equal to 11%. So you're going to enter the returns for each of these so that you can get a sum product for your expected return and make sure that it's greater than or equal to 11%. So again, on this one, you're going to minimize. You're going to have your betas here, and then you're subject to your constraints. And you can run this on GRG nonlinear. That'll be best. So those are an outline of the four problems that you're going to have this week. I want to also recommend that you review both of these video examples. These are really going to help you. Once you've read the chapter and looked through the PowerPoints, go ahead and view both of these videos in addition to my video, because they're going to help you get set up on these problems. So again, this week we're continuing our study of linear programming. I'm available in both the discussion area and by phone and email if you have additional questions. And so I look forward to talking to you in the discussion this week, and have a great week.